you all for joining us today. I think many of you who are running your businesses today are thinking about AI, but what I'm hoping at the end of the session today is you'll start to look at it a little bit differently. You'll start to think about it from a perspective of what can I start doing today in reinventing my business and creating new processes and workflows to actually start to pull AI into your business. It's very early today in terms of where AI is. The question is, and I think we all believe this, we're actually moving somewhere down the road with AI. But we're almost in that in-between stage. And in-between stage, actually, I think that's where opportunity exists for those that are willing to sort of dig into it and look into it a little bit more. So Avi Goldfarb is the Rotman Chair in Artificial Intelligence and Healthcare and Professor of Marketing at the Rotman School of Management, which is the University of Toronto. Avi is also the Chief Data Scientist at the Creative Destruction Lab and a Research Associate at the National Bureau of Economic Research. His research focuses on the opportunities and challenges of the digital economy. Since receiving his PhD in economics from Northwestern University, he has published academic articles in marketing, computing law, management, medicine, physics, political science, public health, statistics, and economics. His work on online advertising won the Informed Society of Marketing Science Long-Term Impact Award, and he testified before the U.S. Senate Judiciary Committee on Competition and Privacy in Digital Advertising. His keynote speeches include the NATO Defense College's 70th anniversary event, the IEEE Aerospace Conference, and the European Commission's workshop on the economics of AI. And of course, Avi's recent research on artificial intelligence includes the best-selling books, Prediction Machines, and Power and Prediction. Thank you, Avi. Thanks.
Just to give you a sense of how I came into AI. So I'm a marketing professor at the University of Toronto. And I made the early part of my career focusing on trying to understand how digitization, how the internet affected the practice of marketing, online advertising, and privacy, and the economy more generally. And then in 2012, we started this organization called the Creative Destruction Lab, which is a program that helps science-based startups scale at the University of Toronto. And in that very first cohort in 2012, there was this company called Atomwise. They're using AI to predict which molecules bind with which proteins, like AI for drug discovery. And the next year, we had a couple more companies saying they were AI companies in our lab. And then a couple of years later, we had this flood of companies coming out of the computer science labs at Toronto and Waterloo saying they are AI companies. To the point where, as far as we know, at the Creative Destruction Lab as of 2015, we had more AI startups than anywhere else in the world. And so my co-authors and I, Jay Joshua and I, said, well, this seems like it's a thing. And no one else knows yet because we're in Toronto and it's coming out of Toronto and it's coming out of Waterloo, and the rest of the world hasn't figured it out. And so we put our heads together and tried to start to do research on trying to understand how AI was going to affect business, was going to affect the economy, was going to affect society. That eventually led to our first book, Prediction Machines, which in turn got us insights into companies trying to build AI into their processes. And there was all sorts of excitement and a little disappointment from many saying, hey, you know what? You started talking about this way back in 2015, 2016. Here we are in 2021. How come the revolution hasn't happened yet? Maybe in 2023 it's happening, okay? How come the revolution hasn't happened yet? And so then we got our heads together and said, well, now we have something new to say. And that something new to say is this book, Power and Prediction, and what I'm going to be talking about with you for the next half an hour to an hour. Okay, so plenty of hype around AI. ChatGPT was released late November. Since then, we've heard things like, generative AI is a game changer that society and industry need to be ready for. Maybe we should be afraid of it because of the AI overlords coming our way. It's the talk of Davos. It seems to be the talk of the world. The excitement around AI seems to generate incredible opportunities. Daniel Kahneman, who won the Nobel Prize, the only psychologist who won the Nobel Prize in economics, said clearly AI is going to win, and how people adjust is a fascinating problem. Well, it's a fascinating problem if you've already won the Nobel Prize. For most of us, it's a terrifying problem, right? If the machines are better than us at everything, what does that mean for us? What's left for us humans to do? A lot of the hype and a lot of that anxiety is driven by confusion about what we're talking about when we're talking about artificial intelligence. We tend to jump to science fiction, and in science fiction, the machines can do just about everything we humans can do. The only real difference is that they're not carbon-based. Otherwise, it seems like there are machines who are artificial general intelligences. Sometimes they listen to us, like they do for the most part in Star Wars. And sometimes they don't listen to us, like is true in the rest of science fiction. But this idea of an artificial general intelligence is exciting. It is possible, but it is not the technology we're talking about in 2023. The technology we're talking about today is a particular branch of artificial intelligence called machine learning. And machine learning has gotten much, much better over the past 2 decades. And we should think about that as prediction technology. Using information you have to generate information you don't have. So I know there is at least one person in this audience who took a stats class with me. And this is a little bit of a reminder of that, okay? That AI seems like today's AI seems like it's so exciting, but ultimately it's computational statistics. It is a branch of computational stats using the information you have to generate information you don't have. Computer scientists are brilliant marketers, they call it AI, but it's computational stats. Computational stats is nevertheless a big deal because prediction helps us make better decisions, and decisions are a big deal. Decisions are everywhere. So the opportunity in AI is to recognize that what's happened is that prediction's gotten cheaper. And because prediction's gotten cheaper, prediction's gotten better and better and better and better, we're going to see more and more machine prediction embedded in everything we do. That was the theme of our first book, Prediction Machines, written around 2018, saying we were just on the cusp of this massive drop in the cost of prediction. Remember, we're economists, so we think about technological change as a drop in the cost of something fundamental. And this is what you may or may not remember from Econ 101. Demand curve slope downward. If something is cheap, you're going to do it more. When the price of coffee falls, people buy more coffee. When the price of machine prediction falls, we're going to see more and more and more machine prediction embedded in everything we do. Point number 1, today's AI is prediction technology. I don't think AGI is crazy. Someday there are good reasons to think it'll happen. But it has been 20 to 50 years away since the early AI researchers were talking about it in the 1960s. And it continues to be 20 to 50 years away. This is not the technology we're talking about today. And so what we're seeing is machine prediction embedded into more and more processes. Go to a bank and you want a loan. In the old days, the loan officer would look you up and down and make some kind of prediction about whether you're going to pay back that loan. Maybe just a gut feel, maybe there was some data behind it or some paper. Increasingly, we're using machine learning tools, we're using AI, we're using prediction machines to predict whether someone's going to pay back that loan. The insurance industry, again, insurance, they're in the business of prediction. That's what they do, they're pricing risk. And increasingly, insurance companies are using AI to help them with underwriting. But as machine prediction's getting cheaper, we're starting to realize that some things that you might not have thought of as prediction are prediction. It turns out medical diagnosis can be reframed as prediction. What does your doctor do when they diagnose you? They take in data about your symptoms, and they fill in the missing information of the cause of those symptoms. That's prediction. Image recognition is prediction. How do you recognize a familiar face? Your eyes take in these light signals and they fill in missing information of a label and a context. Turns out that can be solved with prediction machines. Even language and image generation turns out can be solved with prediction. That's all OpenAI is doing. It's taking data about what people have written in the past in response to a particular kind of prompt and filling in, okay, in response to this new prompt, what kind of information is that person looking for based on the corpus of data out there? Given this question, what's the word? And then what's the word that's most likely to come beside that word? Similarly, if you ask DALL-E, also from OpenAI, I'd like an image of an astronaut on a horse in the style of Andy Warhol. It predicts what you're looking for in terms of an astronaut on a horse in the style of Andy Warhol and provides that image. It is still prediction technology using data you have to generate data you don't have. At the Creative Destruction Lab, we've seen lots of companies lots of startups unpack workflows in existing industries, identify some prediction task within that workflow, take out some human process, and drop in the machine, keeping the workflow the same, embedding prediction in that workflow. And so we've started to see increasing excitement around the technology to the point where people say, this is the new general purpose technology. This is the new steam engine. This is the new electricity. How does that play out? Well, imagine there's some dial. Okay, and the dial's making the predictions better and better and better over time. So one particular example is in Amazon, because Amazon makes recommendations of what they think you might want to buy. These recommendations are pretty amazing. They're right something like 5% of the time. They have hundreds of millions of items in their catalog. You're laughing. Wait. I don't know. You had hundreds of millions of things. Would you be right one of every 20 times? Probably not. It's incredible. Right? Hundreds of millions of items in the catalog, they're right one of every 20 times. But obviously, given the laughter, 1 out of 20 times isn't transformative. Amazon's business model and their workflow is in many ways the exact same business model and workflow when they started way back in 1995. And it's also pretty similar to what Sears was doing way back 100 years ago with the Sears catalog. They're a catalog company. You go to their catalog. It is a fantastic catalog. It has a lot more stuff than Sears did. You order something. They send that information to their warehouse, and they ship it to your door. Now, imagine if instead of 5%, it was 20%, or 40%, or 60%. Well, at some point, Amazon could change their business model. They wouldn't have to wait for you to order. They'd say, you know what, I'm pretty sure I know what you want. I'll just send it to your door. And you don't have to want it. Or you don't have to want it for sure. You just have to be confident enough that they have to get enough of your share of wallet that it's worth it for them to bother to ship it to you, okay, and to deal with an infrastructure for returns. Now, to be clear, Amazon's thought of this. This is a patent for anticipatory shipping from way back, from Amazon, from way back in 2013. You think, wow, they've thought of this for a while. But then you think, from way back in 2013, how come it still isn't there? The prediction technology seems to be getting better and better, and yet this idea of anticipatory shipping hasn't quite happened yet. More generally, when you look at AI investments, the vast majority of companies who invest in AI are disappointed. They say they still haven't seen a financial return from their AI investments. And so even more companies aren't even bothering to adopt AI because it's expensive, and 90% of the time you don't get anything out of it. So why would we even bother? And how does it make sense that all these smart people are saying AI is the new general purpose technology, it's the new electricity, if the vast majority of companies aren't getting much out of AI? Well, let me tell you a little bit about electricity. Okay? So Edison's patent for the electric light bulb was in 1880. Tesla's patent for the alternating current motor, 1890. If you were paying attention in the 1880s, it was clear that electricity was going to be a big deal. It was clear that it was going to change the way we lived and the way we worked. But it wasn't until the 1920s that the median household and the median factory had adopted electricity. It took 40 years from recognizing the potential of the technology until it actually had an impact on most people's lives at home and at work. What took so long? Well, this is what a factory might have looked like in the 1880s. It's not a photograph, it's a drawing, but you get the idea. And you can see that there's a steam engine at the center of the factory, and all the machines are connected by these belts to the steam engine at the center of the factory. And if you remember your high school physics, you may or may not, the longer those belts are, the more energy is going to dissipate. And so the organization of the factory was such that you put the most power-hungry machines near the power source, and you put the least power-hungry machines as far away from the power source as possible, right? You organize the factory around the needs of power. And so what happened in the 1880s and 1890s with electricity? A handful of innovators said, well, you know what? For where I am, for my factory, I can save 5, 10, 15% maybe on my energy costs. And so I'm going to take out that steam engine, drop in an electric motor, but I don't want to mess with my workflow because that'll make me have to figure out all sorts of other things. So take out the steam engine, drop in the electric motor, keep everything else the same. And they did. They saved 5, 10, maybe even 15% on their energy costs. But for the most part, that wasn't worth the bother. And so for most companies, most factories never even adopted. By 1900, we had well under 10% of US factories adopting mechanical drives. But then around 1900, some people started to realize that electricity wasn't just cheap power. Electricity decoupled the power source from the machines. And once you decoupled the power source from the machines, you could do things differently. You could create a different kind of factory. And that's what we imagine. You think about the quintessential 20th century factory, Henry Ford and others. That is a direct consequence of this decoupling of the machine from the power source, because now what you could have is inputs going in one end and outputs coming out the other with modular production and a modern factory system. It required a reimagining of what a factory could be. It wasn't just taking out the old way, dropping in the new way at the same point. It was designing a new system. And at that point, once people started to realize what the new factory looked like, then we started to see an acceleration of adoption. With respect to AI, if AI is going to be like electricity, the transformational opportunities are thinking about new systems, not point solutions. It means we are kind of in the 1890s. We're in the between times. Right? We see the potential of the technology, but it hasn't happened yet because we haven't figured out what the organization of the future looks like. We know it's going to be different. We know better prediction is going to transform the way we live and the way we work. We just don't know exactly how. And that's why we see lots of people hesitating to adopt. And even among the adopters, they haven't quite figured out how to make money off this thing. The vast majority of the AIs I just described are point solutions. There is an existing workflow. They identify a prediction within that existing workflow. They take out a human process, drop in a machine, and leave everything else the same because that's easier. But if you're leaving everything else the same, the upside potential of what you're doing is limited to the fraction of the overall value you're already creating. And so even Amazon, with their recommendation engine, well, if you were in 2003, they would have recommended the Da Vinci Code. They didn't really have an AI-based system, but they knew, look, everyone wanted to read the Da Vinci Code in 2003. And so you just recommend the Da Vinci Code, and it works pretty well. Their AI system, yeah, 5, 10, maybe even 15% better than that. But it's all incremental. The real potential is imagining a new kind of work. These 10% of firms that have reported a benefit are imagining new systems. Almost everybody else is saying, I don't want to imagine a new system. I want an easy win. I'm going to look at my existing workflow, take out some process, drop in a new one, but I don't want to tell anybody to have to do anything differently, because that's hard. So here's an example of a system solution. Well, if you want to drive a taxi in the City of London, it is 3 years of school. It is a very difficult city to get around, one-way streets, all sorts of crazy stuff. And so in the first year of school, it's all maps. It's like studying in a classroom with maps. The second year, you get to go on a moped and start to test yourself around the city. And your third year, it's apprenticeship-like around the city, still studying, learning your way around, because it is that hard to get from point A to point B in London. Not really. It was that hard to get from point A to point B in London. But now we have GPS systems that allow us to get around and figure out the best route at different times of day. And as these systems were originally deploying about 15 years ago, some enterprising entrepreneurs said, well, you know who's going to really benefit from this? Professional drivers. If you're a cab driver, you can save 5, 10, 15% on time from get from point A to point B, and that's going to increase your income and make you better off. And so we had navigational AIs used for professional drivers, applied in the taxi industry. And it helped. But there was a system solution there too. Right? What AI could also do is make everybody as good at getting around the city as London as a professional driver. Made amateur drivers professional. That's a new way to imagine an industry, and that is exactly what Uber and Lyft ended up doing. They reimagined what was possible because of a combination of prediction technology on the maps and digital dispatch. How do you think through in your own industry where a system solution is going to come from? Well, one key starting point is digging into what is it that AI does that creates opportunity and also generates some disruption. Right now, when you make a decision, you have a prediction that you make in your head, but you also have what we call judgment, the other part of a decision that you make in your head, and they are combined. AI is going to separate the prediction from the judgment. And that is hard, it is uncomfortable, and the people who are good at doing prediction and judgment together might not be the same people who are good at doing judgment in the face of a machine prediction. I'll give you an example of what I mean by this decoupling of prediction and judgment. Have you seen the movie iRobot? This is a crowd that looks like you've seen the movie iRobot. Okay, so you have. It's not always the case when I teach my undergrads. Okay. So iRobot it's a fine movie. It's excellent science fiction. Okay, here's why it's excellent science fiction. So Will Smith is a protagonist in iRobot, and he hates robots. And you can kind of see where the movie's going to go based on that. And there's this flashback scene about why he hates robots. Here's why. He and this little girl are in a car accident, and for whatever reason, they start sinking into a river. And it's pretty clear that both Will Smith and this girl are about to drown. And then a robot comes along and saves him and not the girl. And that's why he hates robots. Well, it was a robot, so he could audit it. And he looked at, well, why did the robot save me and not the girl? And the robot predicted that he had a 45% chance of survival. But the girl only had an 11% chance of survival. And that's why the robot saved him and not the girl. 45 is more than 11. But then he says, well, 11% was more than enough, and a human being would have known that. Well, that's a statement about judgment. That's a statement about what we care about, our values, our payoffs. I don't know that all humans would agree that that girl's life was worth more than 4 times his life. But understanding the relative value of things is not something that prediction machines can do. That remains inherently human, and that's judgment. But it's not easy, right? It's useful. It's convenient to have some ambiguity when you make one decision versus another that, I don't know if it was because I predicted that would be better or because I think that person's more important than this person. It's nicer to just say, well, I don't know, there's some ambiguity going on. But what AI does is it forces us into judgment, and it forces us to decide what matters, what we value in the presence of a prediction. Now, how does this example of this, how does this play out? I don't know if you remember a few years ago in Flint, Michigan, there was this water crisis. They discovered massive quantities of lead in the drinking water in Flint. And it wasn't in every house. It was in about 20% of the houses in Flint, Michigan that had lead pipes. The problem was they didn't know which 20%. Okay. And there were no records of whether any given house had lead or copper pipes. And so the city started digging up house by house. And it would cost thousands of dollars in time to go, you dig up somebody's pipes, and then if they're lead, you can replace them, and if they're not lead, then you just put the dirt back on and go to the next house. It's a slow, expensive process. And so these 2 professors at the University of Michigan built an AI to predict which houses had lead. And it worked. Their AI was 80% accurate. Okay. So the baseline was 20. So it was 4 times better than just digging randomly, which is what they were doing before. And it seemed like, well, that was the end. Hey, we finally found an application of AI that makes life better. But then some people in the city started saying, well, how come the people in the next neighborhood over, they're getting their pipes dug up, but my pipes aren't getting dug up? Or the people in the street, the next street over, they're getting their pipes checked, but my pipes haven't been checked. And they started to complain. They complained to their politician, said, hey politician, how come this neighborhood that voted for you, we're not getting our pipes dug up? But these other neighborhoods, they seem to be getting their pipes dug up. What did they do? This isn't fair. Why should we be listening to some professor from a different town's algorithm? That doesn't seem right. And so the politicians said, you know what, you're right, that isn't fair. We're going to take the power away from these professors, from the algorithms, and we're going to keep making the decision in the best interest of the people of Flint, which is to go the way we were, systematically, house by house, neighborhood by neighborhood, potentially started with the people who voted for me. Okay. Hard to really tell if that actually happened. And the success rate plummeted. It went from 80% to 20%. And this is consequential. It meant that thousands of people in the city of Flint were now drinking toxic water, and they should not have been drinking toxic water. But the story didn't end there, because it's so clear, given the predictions, what the correct judgment is. And it was clear that the politicians did not have the correct judgment, so people sued, and the people got the power back. A judge came along and said it is now the law in Flint, Michigan, to listen to Jacob and Eric's algorithm. That algorithm, that AI based at the University of Michigan, it is law in Flint. And then the company grew, and it's now used in dozens of cities around the country and around the world. And of course, once they were using the algorithm again, the success rate shot right back up. So this is a case where AI, because it decoupled the prediction from the judgment, the politicians' ambiguity of, we don't really know where the lead is, so we're going to dig in the neighborhoods we want to dig in first, that power was taken away, and it was given to the people who ultimately were the ones who were drinking toxic water and needed their pipes replaced. Story of decoupling prediction and judgment. Okay. So AI helps us make decisions. It decouples the prediction from the other parts of the decision. Now, I imagine the question most of you are thinking about is, should I worry? Is this coming from my job in my industry? It's hard to tell on a one-on-one whether we're going to exactly how that's going to play out. But here's a framework for thinking about it. Think about what you do. Think about the mission of your organization. And try to understand how much of your day-to-day activities serve the mission and how much of your day-to-day activities exist because you fail to deliver on the mission. For example, this is, by many accounts, the best airport in the world. This is Seoul Incheon Airport. It is pretty spectacular. It has great shopping, great restaurants. There's massage chairs. It's a fantastic hotel. There's greenery. It is a multi-billion-dollar place that, if you're at an airport, it's about as wonderful as it could possibly be. But this is the airport all of you would rather fly through. This shed, I'm told, is the private terminal at Boston Logan. This is how the super rich fly. They don't fly in multi-billion-dollar airports. They fly through sheds that don't have any services. They have a magazine rack with the same magazine over and over and over again. How does that make sense? Well, the reality is no one wants to spend time at an airport. The mission, even the mission of Seoul Incheon Airport, is to ensure smooth air transportation. And the vast majority of the billions of dollars they spent on building that airport are dealing with the fact that they fail. That they fail to deliver on smooth air transportation. You're stuck at the airport because you don't know how long it's going to take to get there and through security and to your gate. And because you're stuck at the airport, they try to make it as pleasant as possible. But their procedures are based on failure. And if you had a good prediction about how long it would take to get to the airport through security and to your gate, you do what the super rich do, right? You just step right up, walk in the plane, and take off. This happens industry by industry. Think through how many of your standard operating procedures are dedicated to the fact that you're not delivering good customer service. And whenever that's happening, you should worry. And then you think through, well, if we had better prediction, is someone else going to come along and serve our customers in a way that we overwhelmingly fail at? Now imagine you go to your doctor. Your doctor looks at your blood work, goes over your symptoms and said, well, there's a 5% chance that something catastrophic is going to happen to your health over the next year. If that happens, we'll write you a check for $500,000, and okay, we'll see you next year. Be like, well, that's not right. That's not the way things are supposed to work. You're supposed to tell me what's wrong with me and provide some kind of treatment plan. But okay, luckily, that's not how medicine works today. But it is how home insurance works, right? Your insurance company has all sorts of data about your house. And they use that data to predict the risk that something catastrophic is going to happen to your house. And then they say, we're providing peace of mind against that catastrophic loss because when it happens, we'll write you a check. Well, okay, it's better than not writing you a check. But given they have all that data, why aren't they telling you, you know what? The reason your home insurance is expensive is because I think you're at risk of leaky pipes. And the reason your home insurance is expensive is because you're at risk of an electrical fire. And it turns out we have tools to reduce the risk of leaky pipes or an electrical fire. And we can install a water monitor into your house. And if the pipes start to leak, it detects that. It'll shut off your water. It's cheap. It costs less than the extra cost of the insurance. But it's not happening. Right? The insurance companies, this is their mission. But for the most part, they're not delivering. What they're doing is what was possible 50 or 100 or more years ago when they didn't have the data they have today. And that becomes hard because in an insurance company, underwriting is the central function. But what I just described about not just risk pricing, but risk reduction is largely about behavioral change. That requires excellent marketing departments. And many insurance companies don't have powerful, excellent marketing departments. And so now we need to redesign our organization around that. And it's a real barrier to innovation and change. So whatever industry you're in, right now you're thinking through, I'm in the 1890s, here are my processes, where is there a prediction that I could take out whatever I'm doing now and drop in the machine? And that might be a first step. But if that's where you stop, you're going to decide not to bother again. The impact of AI is necessarily incremental if you're not thinking through the new opportunities it can create for new systems. And so think through in your industry, what does that factory of the future look like? Once we've decoupled the prediction from the judgment, what can we do differently in order to serve customers in our industry better? Thank you. We've got lots of time for Q&A. Okay. Questions? Oh, yeah.
Are we really in the middle of something?
Oh, yeah. So,
And-
okay.
And sorry, that feels to me,
Yeah.
what I've read about that is a request for proposals to take all the intelligence and to revamp the whole medical system, the British health system.
So I hadn't heard about that. My sense is it hasn't happened yet. And there's all sorts of ways to reimagine what a prediction-enabled healthcare system looks like. Exactly what the right one is going to be is still an open question. And so the British health system is going to experiment with one thing. Maybe in Ontario we'll experiment with something else. Maybe Cleveland Clinic in the US will experiment with something else, or Kaiser with something else. And some of them won't work as well as we'd like. And some of them require all sorts of other changes. So for example, in medical diagnosis is prediction. And a lot of what we select doctors on is their ability to predict, essentially, respond quickly in a test type setting. So that's why we get the people who get the 98% grades. They do really well in their MCAT. They have all sorts of studying to do as part of medical school, and then they graduate after 10 years post high school or more. And they're doctors. Okay. Now, if the machine's doing diagnosis, it's an open question about whether we need 10 years of post-high school training for those people who help you navigate the healthcare system. The doctors will say, well, I do much more than prediction. I do much more than diagnosis. But the main thing I do is help patients deal with the stress of a health crisis. And I think, well, yeah, that's great. But your training isn't, and your selection isn't for dealing with the stress of a health crisis. I think there's people who are trained as social workers or psychologists or something else who might be much better at that. And you can imagine a 4-year degree, undergraduate degree, that gets people ready to do all sorts of things that doctors do. Okay? So that's a proposal. Good luck getting that through in the next few years. Okay? So but I agree with I agree with you that finally, outside of the online advertising industry, people are trying to imagine how AI might revamp the way they operate. And for the last 10 to 15 years, it was, advertising transformed, but many other industries were still stuck in thinking about point solutions. Great question. Yes?
What are your thoughts about AI in the military and how fast that is evolving? You keep hearing about more and more drones and the moral concept of taking soldiers at harm's way.
I just want to make sure.
Okay. Yeah, so the question was, what are my thoughts on AI in the military, in the speed with which those changes are happening, and then the moral consequences of that. Okay, so I'm going to say I'm glad there are a lot of smart people thinking about the moral consequences of it. That's not my expertise, so I'll just say I don't know much about that. I know about the economics of it. And here are a couple of important forces on the economics of it. So this is prediction technology. It's not providing judgment. So the first thing you need to recognize, it is not a machine decision. It is a human decision. What the AI does is it changes, or can change, the time and place of the decision. So you could have a human pre-specify to a drone saying, if you identify this target, you can shoot. That is not a drone making a decision. If we think it is a drone making a decision, that's a human figuring out how to abdicate responsibility for what might be an awful action. Okay? It is a human who's providing the judgment in advance for a machine when a machine makes a prediction above some threshold to act. Now, so that is happening. Let's be, the military AI is happening. There's an extreme, so usually when we think about the risks of military AI, a lot of the conversation is, well, what if we lose control because we get AGI? And as I said, like, I'm glad, again, smart people are thinking about that, but that's not where we are or will be in the short term. And what happens if machines make mistakes? Okay. So machines making mistakes are a big deal, just like humans making mistakes are a big deal. What's in the military, in any context, but especially in a military context, what's particularly tricky in for AI in military, as opposed to most civilian applications, is you have an adversary who doesn't play by rules. And what that means is they're going to try to mess with your predictions, effectively mess with your data, and they're going to try to mess with your ability to judge, which means that you're off the map of what we usually think of as prediction technology, and you're now in a world of a different kind of stats called causal inference, which prediction machines don't do that well at. And so when we have an adversary, these tools often break down. And so a lot of the short-run applications of AI in the military are pretty boring. They're things like, we don't have enough recruits. Let's use AI to help us find people who want to work in the military. Or let's help us with logistics and inventory, because there your adversary is going to be less important about messing with. Yeah?
They say data is the new fuel, and
Yeah.
AI, data is key. A lot of small, medium businesses, the organization of data is not necessarily the strongest suit. What would you recommend, a small, medium business that wants to take advantage of AI really focus on?
That's a great question. So, to the extent that you don't want your business, you don't want to be an AI business, but you want to be a business that takes advantage of AI, think about buying someone else's predictions. Okay, so rather than building in-house based on the data you have, there's going to be situations where that's true, but often the biggest opportunities from AI aren't about building the AI yourself. It's about figuring out, hey, you know what, I have a complement to AI. I can do something better once we have better predictions. So for example, in the pharma industry, so one version of it is pharma companies are going to use AI to try to predict which drugs are going to work and help build better medical devices. Okay? Yes, that's direct. But maybe the bigger opportunity is to recognize once we have prediction at scale, once we're really good at identifying relatively rare diseases, now we can do what we do well, which is develop treatments for those relatively rare diseases, because they're going to be diagnosed at an entirely different scale. And so that's a company that's taking advantage of, that's an idea of taking advantage of prediction technology without having any AI expertise in your house, just taking advantage of the fact that, hey, there's these new predictions coming, and we can be in the business of using those to sell what we always sold and do what we always did. And so I think for many small and medium businesses, that's where the opportunity is going to lie. Thinking through, well, once there's better predictions out there, where does that give you an opportunity to provide a complement to those predictions?
Yeah. How small business can use AI?
Yeah.
How small business use AI? Because AI based on data, so small businesses don't have a lot of data, so it's very limited, right?
Yeah. So, so one version is effectively you're buying someone else's predictions. So for the most part, small businesses aren't going to build their own AI tools. But they're going to figure out what parts of their workflow, what parts of the value they deliver are now even more valuable because your customers or you yourselves can take advantage of better prediction. Okay, so if a lot of what you do is right, well, you can now write much better at scale because there's ChatGPT. If a lot of what you do is, if within your workflow you generate lots of images, well, now we can use DALL-E and other tools to have those images provide graphic design to you and the people who you work in an organization at scale, cheaply for like $100 a month. Okay. So it's, for the most part, small businesses aren't going to be building their own AIs. That's probably not worth the billions of dollars required to build it. But there are lots of opportunities to take advantage of the predictions that others are building in order to build new systems for your own customers. That helps. Where are we? Over here, Andrew.
Hey,
Hi.
Avi. So when I read your books and in conversations with you, I always end up feeling a combination of enthusiasm and optimism, but also feeling overwhelmed. And I know from everything we read and even from the looks on people's faces in here, they're probably feeling the same thing. So I'm hoping you can help us make it a little real. I was thinking of, based on the case studies that you have such amazing exposure to, right? The stories that you've read and heard and been involved in. Can you share with us some sort of tractable opportunities for us as business leaders, maybe making decisions about who to promote, maybe
Okay.
from an HR perspective? I mean, I'm
Right.
going
Yeah,
to
yeah.
give you three. So there's
Okay.
that one.
Okay.
There's as a thought leader,
Yeah.
and the third one is as a parent.
Okay. Okay. So HR. The way that people generally think about the opportunity for AI in HR is you get a ton of resumes, right? And how do you figure out how to screen through those resumes? You can use an AI, whether it's an HR analytics company you can hire, or you can build one yourselves, depending on your needs and how many resumes you have coming in, to predict whether someone's going to be a good fit for your company. Okay. And how do you typically do that? You predict who your current HR department would hire. So you get these resumes coming in, and you'd say, well, out of all these resumes, which ones look most like the people we've already hired? Okay. So that is a point solution. It's within your current workflow, the way you already do things, and you can make it a little, and you can make it a little bit more efficient. But if you're like many organizations, you have some challenges in hiring. In particular, the people you hire tend to look like the people who are already in your company. And that's a problem, right? So we humans are biased in all sorts of ways. And so when we have an AI predict what we humans do, it's just going to replicate our biases. Not necessarily worse, but no better. But a system-type solution with AI is to recognize, well, for every one of those resumes, the AI is giving us a best guess, an estimate, but it's also giving us a variance. It's stats. It's giving us like for this person, I really know they're going to be a good but not great employee. This person, they might be great and they might be awful. We have no idea. But for most hard-to-get jobs, those people who might be great and might be just okay don't get the job. Okay. But if you're an organization that has overwhelmingly hired, say, men, and there's someone with a different kind of resume, a female applicant, well, maybe your variance, your guess on that, this person could be awesome, and they might be just okay. And in a standard hiring process, you'll say, well, they might be just okay, it's not worth the risk. But you can deliberately, once you have an AI, say, you know what? We're going to try to train our AI to learn which kind of unusual applicants are actually great in the organization. And this is a different kind of hiring process because it's not just about who's going to be great today. It's deliberately hiring people who we have no idea if they're going to be great in the company. Okay. And you hire people in order to learn and train your AI how to get better and better and better and better. And that's not fiction. That is something that has happened at a large consulting company. They have lots of applications. They had this issue that their AI was replicating the biases that already existed in HR. And they did what they call hiring as exploration. Hiring people who they just didn't know if they'd be good in order to learn who would be good. They made mistakes. That was the whole point. But over time, as a consequence of that, they ended up with a much more diverse workforce. Okay, so your second was thought leadership. Okay, thought leadership. Talk about my book. So there's thought leadership. So try to figure out what it is in, where does prediction sit in your industry, and what you can say around that effectively no one else can. Now, the easier answer, though, maybe, is here's your starting point. We had the question, who's used ChatGPT? Okay. If you haven't, you should. It's amazing, and many of those around you are doing it, and that's why you've noticed, or maybe you haven't, their blog posts are better than they used to be, their emails are better than they used to be, they seem to be writing more frequently than they did before. It has just been a transformative change in producing text. It doesn't produce ideas. Those have to come from you. But once you have that idea, getting your first draft out through ChatGPT, here are my 3 bullet points. Can you write a 5-paragraph essay about that? You can get it. And then you take that 5-paragraph essay, you got to edit it. You can't just take it as is, to be clear. But that's a real transformative change. And then, then parenting. So expect your kids to use these tools at school. And if your kids aren't using these tools at school, then their peers are, and that's a problem. They're falling behind. And so, I don't know, parenting, but I'm thinking I put my professor hat on. Many of my colleagues are saying, well, we have to, using ChatGPT is cheating. Right? We ask them to write essays, we want them to learn how to write, and they use that for a take-home assignment. That's cheating. We got to forbid it and then try to catch them. Okay, from my point of view, that's going to be a losing battle. Instead, the opportunity is to say to my students, last year when you handed something in and you had those grammar mistakes and you didn't have a clear thesis statement in paragraph 1 and it was a 5-paragraph essay, but it didn't really make sense and you ended up with 7, no excuse anymore. You can put whatever you want into ChatGPT. It will give you a well-written, coherent text. So from now on, if you're not using it, it means you're just missing the point. And so from now on, as a student, for my students, my expectations are higher. I expect you to use these tools, and I expect you to be much better than before. You need real new ideas, or else the entire class is going to have the same text because they put the same query into ChatGPT, and then I'll figure out that no one's really doing anything interesting. Yeah?
I have a couple of other suggestions for the lady here in terms of practical application.
Fantastic.
Chatbots, right?
Yeah.
Chatbots, you probably all use them, and they're very affordable, easy to implement, easy to use, easy to train on your data. So if your website does not have a chatbot, I would say get one.
Yeah.
Because it increases sales exponentially, and it's easy to implement, and it's way more affordable than it used to be.
Absolutely. Yeah.
Just like the taxi example, where AI was targeted towards professionals, but it resulted in a side effect of amateurs getting better.
Yeah.
Have you seen anything similar in the legal field, where using this, self-reps are increasing in quality, and on that note also, the decoupling concept. Yeah. Is that leading to, I know it's a bit of a hyperbole, but does that lead to maybe no requirements with judges in the future? Because then you can just analyze a case and be like, 51%, 55%, etc.
The legal tech industry has been taking advantage of AI in all sorts of ways. So there's Toronto-based Blue Jay Legal that's using AI to predict the outcomes of tax cases, for example. But ultimately, that company is constrained by the law, and the law says the AI can't be your lawyer. Okay. So what they do is they provide support to an existing legal team, and they actually make current lawyers better at their jobs. Okay. Now, another major transformation in law has been in disclosure. Okay, so we used to have teams of students in law who would read documents with a black marker and black things out. Okay, that was how we trained our young lawyers. They had to read documents to figure out what couldn't go to the other side. Okay, Most big law firms are now using AI to do the blacking out. And then, yeah, you have a human who goes and looks through and says, do we really need to or not? But it's a lot less time consuming, which is good. It's a lot more efficient, which is good. But we haven't figured out how to train young lawyers to read lots and lots of documents and still figure out a way to get paid for that. And that's been a real challenge in the profession and a real source of angst, actually, at in law education. And as for judges, judges also do judgment. So it's not just prediction. And so even in the presence of a prediction, the judges still have a role in the ultimate decision, at least for now. Yeah.
Hi. So,
Hi.
First of all, I want to say great talk. Loved
Thank
it.
you.
I run a technology staffing company, and one of our fastest growing jobs in the last month is being ChatGPT prompt writers.
Yeah.
And so,
Yeah.
having said that, so a lot of you are talking about, with your kids, and with your students, this is the future. But it's here now.
Yeah.
And they pay really well. So it's something that's coming and it's going to grow. I think they're going to have them in every firm. You're still going to have to be able to code, or you're going to still be able to do marketing, but you need to be able to write good prompts. So my question to you was, are there other jobs that you see that are going to be coming in the next 12 months, 24 months, that aren't like 6 months ago we weren't getting requirements for this?
Yeah, let me think through how to organize them. Okay, so I think there's two types. Okay, there's the type that you just described, which is we have new generative AI tools. We need people who can use those generative AI tools. So ChatGPT prompts, graphic design through DALL-E, whatever else. There's going to be a whole bunch of jobs around that. In every new iteration, right? We just had GPT-4. Google and Facebook are going to come out with their own, and there's going to be people who specialize in Bing and people who specialize in. So there's that whole suite of jobs. There's another set of opportunities that are not so much about prompts for text, but might be more around coding. So with GPT-4, it can code pretty well. Doesn't code. You still need to know something, right? So if you have GPT-4 create Python code, you still need to know how to load Python onto your computer. Okay, it could explain it to you, and it might take you, if you're semi-tech savvy, it would take you half an hour to figure it out, and if you're not, it might take a couple of days. But it's good enough to the point that when it came out, my 13-year-old son said, "Hey, I'd like to create a choose-your-own-adventure game," and it created code for a choose-your-own-adventure game. This wasn't prompt engineering. This is just the ability to think through what I want to do in software. Okay. And then he ran it in Python, and it worked. That was kind of crazy. He said, but wait, I don't like this. The monster's this way. I want the monster to be that way. Okay. And I want there to be 4 endings, not only 2. And he just wrote, hey, I want there to be 4 endings, not only 2, and I want the monster to be this way. Created new Python code, ran it, and it worked. Okay. Now, that was okay. So first of all, that was like the mind-blowing moment for me in using this, because let me be clear, he doesn't know how to code. But the job opportunity there isn't so much prompt engineering as how do I get something useful out of this thing. It's now that we can do software at scale, or graphic design at scale, or writing at scale, what are the new set of opportunities that unlocks for both, at the organization level, and that's for you guys who are running the organizations, but also at the entry level, and empowering them to do much, much more than they could do before. Sure, whoever was the next.
You mentioned
Hi.
electricity from
Yeah.
1880 to 1920, 40 years, but what we're seeing here in ChatGPT couldn't pass the bar. Now GPT-4 can pass the bar. do you not see it being exponential? And if so, how do you keep up on where it's heading and what's your source of information other than your books?
Well, okay, so there's two parts to that question, which is part one is the pace, it was 40 years for electricity, is it only going to be 3 for generative AI? Okay, so I'd like to think it'll be faster. We've already been 10 years, like the, Hinton's paper that sort of broke out what you can do with images was 2012. But despite what's happening with the technology, we can see the technology is amazing. That still feels a little bit like the 1890s. Electricity was amazing. We had the telephone and the electric light bulb and the electric motor all happening back to back to back to back to back, but it didn't make a difference in most people's lives for another 30 years. And what took so long is for most organizations, they just couldn't figure out what do you do with it. And it didn't impact most people's workflow. So the reason I'm optimistic that this is going to happen faster is we know what happened. We have history from electricity and from steam engines, and we recognize that if all we're doing is just keeping our workflow the same, taking out something, putting in something else, for the most part, it's not going to make much difference. Okay? So talking about chatbots, chatbots are awesome, okay? But in the sense that it's making customer service much more efficient. But if all you're doing is the exact same customer service and just predicting what your human would have done, then it's going to be pretty underwhelming. And yeah, it'll be worth it, but it won't make much difference in the grand scheme of things. And we want to think through, well, now that you can do customer service at scale, how many more services can you provide your customers? How much more complicated even could you make your products? Because people can just ask the AI and get feedback right away. Okay, so and your second point was, where do I get my information? Okay, so I'm very lucky because I sit in a university, and it's a university that's at the center of this innovation, of this AI system. So I see it in lectures by computer scientists and others at Vector and elsewhere and around the world. But the other thing I get is I'm the chief data scientist at the Creative Destruction Lab, which is this program we have for helping science-based startups scale. And a big part of what we do at the lab is take things out of academic departments, take like basic research, and try to turn that into commercial products. So I saw AI first in the lab before most other people did. We have a quantum computing stream. I've had that I've had exposure to that for 6 years. It's still a while away from filling a room like this, but it's a thing, and we've been able to see that there. And within AI now, with when you see what all these startups can do, you can see, okay, well, originally it was really about these simple predictions within existing systems to help with the legal industry or the pharmaceutical industry. And increasingly they're getting more ambitious. Increasingly they're starting to be embodied, use robots. Increasingly, well, now they're starting to do things at a scale that was impossible before. The sort of at-scale graphic design, at-scale writing, at-scale coding. So that helps. But those are my sources of information anyway.
Hi there.
Hi.
I was wondering what your thoughts might be on what the next thing to break through into the sort of the general population's consciousness might be. We have chatbots, obviously, because they're very accessible. People know how to text, that kind of thing. Dolly and Midjourney are there, but because you have to go through a Discord server or whatever else, it's more awkward. I'm just curious, from your perspective, what do you think might break through next?
Once people figure out how to take the code and make an easy an easy user interface so that anybody can code without having to do the cut and paste to Python, that's going to be amazing. Okay, I don't know if that's going to be 6 months from now or 6 years from now, but lots of people are working on that, building.
A lot of talk about Copilot and other things like that. So you think that that's going to be a big? It
means anybody can create any software. Can create not any software, but the kind of software that like a fourth-year computer science undergrad can make, and that's incredible.
Hey, hi. So, moving from a point solution to a system solution is like making the AI accessible to many people. So, with AI being computationally intensive and making it more expensive, how do you think we can make it more democratized so that the organizations can try it out with less expensive ways and figure out a way for it and report the value out of it? So, how we should approach about that?
Okay. What Microsoft and Google and soon Meta are trying to do is make it easy, and OpenAI is as part of Microsoft or not, depending on how you look at it, are trying to make it easy to build, to experiment with these systems. Okay, so in some sense, that's exactly what's happening for the big tech companies. There is a missing piece still for many things except for chat, which is a user interface that makes it easy for most of us to experiment and deliver products. But what they are, so there is a layer of developers that need to figure out how do we plug into these tools, like just like what happened with the cloud at some point. How do we, or with the internet, how do we get people to plug in and develop these tools so that many people can try it out? There's no profits in the trying it out, but the profits is in once they try it out, figure out something useful. So I think that's what the tech companies are trying to do. If that's, I don't know if we're out of time. I think so. Okay.
Well,
Thank you.
I just wanted to thank you very much.
Thank you.
Aird Berlis is a prominent Canadian law firm with a well-established local, national and international practice. We provide strategic advice in all principal areas of business law. Regardless of size or sector, our professionals are dedicated to providing exceptional client service. Let us focus on your legal issues, so you can focus on your business. Contact Tony Joya or Bill Chalmers to discuss ways we can work together. Please visit airdberlis.com for contact information.